Good day to everyone. I am Edward Atienza. I am a practicing civil engineer in the Philippines, and I am a practicing structural engineering. And now I am trying to study more on foundation analysis and design. So will be my third video, and before I have my first video before was more on earth pressure. So my third video will still be on the earth pressure, and this is an active earth pressure diagram. Then there will be a tension crack. So we're going to discuss what will be a tension crack, manual with the given manual calculation, and at the same time we're going to check it with a software. Then now let's try to have a definition first. So on what is a tension crack? So in soil mechanics, this is one of the trench failure. So, kung gaano kataas yung nagiging height ng trench natin, then there will be a designated failure na babagsak yung ating lupa. So, this is the part kung saan masasabi natin na magkakameron tayo ng tension cracking. So, paano ba natin mako-compute ito? So, let's try to use one of the problem in uh, one of the books of Joseph Boyles, which is Foundation Analysis and Design. Okay, so this will be the example problem. So draw the active earth pressure diagram for a unit width of wall for the conditions shown in figure E11-4A. Compare the several possible alternatives that are produced from this problem. So this is the tension crack, how the diagram might be modified, and water in tension crack. So this will be our tension crack. Then on the top of it is magkakameron tayo ng water in the tension crack. Kasi there are times that even if we have this trench, magkakameron tayo ng pag umuulan, then there's the tendency that that will produce the tension crack. So on our book, we have most of this is educational purposes. So para manually and with the use of a software, mas ma-determine natin, especially if we are not those familiar on paano ba itong mga calculation and computation. If we want to make it more reliable and maniwala tayo sa ating mga calculation and analysis, at least we still have a manual and uh, the software that we're going to use. So this is a sample from the book of Joseph Boyle. So at the top of the elevation, which is zeros, and then this is the formula for our active earth pressure. Then determining the height of this tension crack, then we are going to use still the active earth pressure kung saan the value of the P will be zeros, and we're going to find the value for the tension crack, which is 1.43. Then at the same time, we're going to have the soil pressure on the 6.5 meters, because on our problem we have the height of 6.5 meters. Then this is the soil properties. Our internal angular return friction is 10 degrees. Then our cohesion is 10.5 kPa. Then the unit weight of soil will be 17.52. So manually we have all of these values that we have found. So if we're going to look on my manual calculation, so here, so meron akong height of the elevation, then which is 0, then 6.5, then the height of 1.43. So these are all the values that are found on our problem. Then the calculations, or if we're going to look at the computed value, ito rin yung mga values na nakuha natin. So the y bar and also the resultant is almost the same. And also for the using alternative pressure diagram, kung saan yung at the top will be the overall height, then the height of 1.43, then ito yung makukuha natin. Then we have the resultant, which is 168.67 and almost the same as 168.5. Then the moment of 132.98. So on the book is 123.3, so almost the same. Then our centroid will be 1.92 and 4.59. So this will be the total height from the centroid of our diagram here. So to be more specific on our, or to become mas kumpiyansa tayo sa ating mga design analysis, let's try to check it on our software. Dito sa software, what we're going to use is GEO5. Wait lang. Okay. So this is our GEO5 software. So I am using this GEO5 just to make para mas maintindihan ko kung ano yung mga parameters, the calculations, the active soil pressure. Dahil minsan kung hindi natin magagamit on if manual calculation lang, kung hindi natin nakikita, medyo minsan hindi natin talaga ma-realize kung ano yung mga values na nakikita natin. So, let's try to go on our GEO5. So here, makikita natin, I open up yung earth pressure. So dito sa earth pressure na to, so on the task, sample project 1, then description soil tension, then author, my initials, then this is mostly the interface of our GEO5. So the first thing that we need to go is the project. Okay, then click on the second tab, which is the settings. Then this will be the analysis na gagamitin natin. So mostly this is the analysis that we're going to use. So at least lang natin, wag muna natin palitan. So next, this is the geometry. So on the geometry, our height will be 6.5 on height. So let's try to place the 6.5. So 6.5. Then okay, you can double click the number 2. So ibig sabihin, ito na yung height natin. Double click, then 6.5. Then it will be in meters. The next will be the profile. Here on the profile, wala tayong gaanong babaguhin because we have only one kind of iisa lang naman yung ating gagamitin na soil layer. The next is the soil. So here on the soil, so add. So this is what you're going to have all of the parameters for the soil parameters. I-close ko lang siya. Okay, then double click ko siya. Dahil meron na akong na-input dito na mga data ng soil. So our unit weight will be 17.5. Then the angle of internal friction will be 10. Then the cohesion of soil will be 10.50. Then the saturated unit weight is placed din natin at 17.52. So almost the same. Then okay. Then next is assign the soil. So automatically lalabas na yung magde-designate na siya ng S1. So isa lang naman yung ginamit natin na soil profile. Then next is on the terrain. So wala naman tayong sloping na terrain, so plain lang siya, so at least pa rin natin. The next is the water tab. So here on the water tab, try to check the tensile crack, then add 1.43. Saan natin nakuha tong 1.43? If we're going back on our book, so ito yung 1.43. So paano natin na-compute yung 1.43? So kung titingnan natin dito on our book, it is computed na ang ating pressure pa is substituted as 0 pa siya. So ito yung calculation na makukuha natin to find this tension crack distance. So manually, kung titingnan natin dito sa Excel file, okay, on our Excel file, so this is the formula na sinubstitute ko lamang dito sa given formula ni Joseph Boyce. Okay, then go back to JU5. Then surcharge, wala naman tayong any kind of pressure or load on the top of the soil. So okay lang. So earthquake, let's try to neglect it first. So wala pa naman tayong earthquake na gagamitin. Then stage setting, so at ease pa lang. Then let's try to analyze. Then this will be our analysis. So meron tayong horizontal component na 168.68, then 4.58. Then ito yung ating mga pressure, and at the same time this is our forces. So if we are going to look, for our book, okay, and let's try to compare the values that have been the result of the values na nakuha natin. So here we have the 158 for the pressure, wait. So nakalagay dito overall force. So the overall force is 168.5, and if we're going to look at the PDF file, we have 168.5. So it's almost the same. 168, then sa JO5 is 168.86. Then on the bottom pressure, let's try to go here up. So 62.53. So dito naman sa JU5 is 62.56. Then dito naman sa book is 62.53. So it's almost the same. Then if we're going to look at the sa mga forces, so 158.52, while on JU5 it's 158.64. Then meron tayong water pressure sa may tension crack, which is 10 kilonewton. On JU5 it's 10.23. So here we can be more a better result. So we have a calculation from the book, a manual calculation on the Excel, and then also for using JU5. So this is the way on how we can understand foundation engineering, not only for the software but also for the manual calculation. So I will be ending all of my video for today. Then I hope sana meron kayong natutunan dito, and try to wait for my next video for understanding foundation analysis and design. So there will be I will be getting an example from the book of Joseph Boyles. Then I will make a manual calculation, and at the same time I will go to use it JU5 as a software para ma-verify natin na tama yung mga calculation, and even the JU5 is also using the same output and result. So that's all. Good day for everyone.